All right, we're going to run through a few different problems where we're trying to figure out if the relation gives a function or not. So first, the relation y equals x to the fifth. If we sketch the graph of y equals x to the fifth, it looks like the graph of y equals x to the third. The main difference is that it sort of flattens out more at the origin. It also goes up more steeply and down more steeply. But our job here is to figure out if this gives a function or not. Because the picture passes the vertical line test, this relation does give y as a function of x. And then to get the domain and range, we can see that you can plug in any x value and get out a y value. So the domain is all real numbers. And then from the graph, you can see that the range is all real numbers as well, because the y values go down forever and up forever. For x equals y to the fifth, the graph of that looks like the graph of y equals x to the fifth, but the roles of x and y are swapped. What that does is it makes it so that as x goes positive, well, it takes the graph, and instead of making it go up the y-axis as you go to the right, it's going to go up the x-axis as you go up, basically. So instead of a vertical stretched out function or graph, it's going to be horizontally stretched out. But still, when x is positive, y is positive. When x is negative, y is negative. It does pass the vertical line test, so it does give a function. It does give y as a function of x. The domain is still all real numbers because you can plug in any x value and get out a y value. Notice you could actually algebraically solve for y here. Just take the fifth root of both sides. And if you did that, you'd get y equals the fifth root of x. You would not need plus or minus the fifth root of x. Just positive fifth root of x. And then range, all the y values get hit there. So that's also all real numbers. Then for y equals the square root of x, that's the top half of a sideways parabola. That does pass the vertical line test. So that does give y as a function of x. And then the domain is, the domain starts at 0 and goes out to infinity. So we're going to include 0 with a bracket and then go from there to infinity. The range also starts at 0 because the smallest y value on the graph is 0. And that will include 0. So the range is also 0 to infinity. Then for the last one, the relation is not an equality this time, it's an inequality. Y is less than x. And you may have never graphed an inequality before. If you haven't, that's fine. What you should do is first sketch the equation with a dotted line. So if it said equals y equals x, this is what it would look like. But now what I want is all of the points where y is less than x. So on that dotted line lies all the points where y is equal to x. If you go below that line and you grab any point, the y value is less than the x value. So I'm shading in everything underneath that line to say that all of those points are satisfy the relation. So if you try to run a vertical line through any piece of this, it's going to pick up infinitely many points. So that means that this does not give a function. Y is not described as a function of x here. We can still pick up the domain and range though. All x values are valid here. No dividing by 0 or square roots of negative numbers. So the domain is all real numbers. The range is the set of all y values that get hit by some x value. And you can see that as you move out to the right, you'll pick up all possible y values. So the range is also all real numbers there.